In this tutorial, we're going to use DFM concurrent costing to analyze a sheet metal part. Now, I've gone ahead and started an analysis and loaded a picture in here of a sheet metal spacer plate. We can see it's 4 by 4 inches, 188 thousandths thick. It's got 5 holes in it. 4 are 3/8 and 1 is 1 3/4. So what I'm going to do is use DFM to analyze the cost of making that part as a piece of sheet metal. So we'll start out here calling it the spacer plate. And let's say we want to make 1,500 of these pieces. They are 0.188 thick, and the average thickness is equal to the envelope height for a flat piece of sheet metal, and it's 4 by 4. I would then select a process and a material. The software will load the material library for me, at which point I can choose a manufacturing process and a material. Now, for a relatively low volume, 1,500 parts, I might choose a process like laser cutting, and let's just go with a generic low carbon steel as the material. If I say OK, I'm going to get cost right away. The software will take a guess about what the laser cut data would be here, and based on those guesses about the area, perimeter of the blank, the number of holes, and so on, it's calculated for me here a cost on the left-hand side. Now I can go through and change any of the inputs I see here on the screen to refine my estimate of the cost. The batch size, the material cost, the scrap value. The software has automatically selected the optimal sheet size for me. I can uncheck that box and choose a different sheet size from the drop-down if I'd like, or I can just allow the software to make the optimal selection. It's picked a part-to-part and part-to-sheet edge clearance for me, and based on those and the sheet size, it's saying I would get 8 by 8 or 64 parts out of a sheet. Now, if this part were bent, one of the first things I'd want to do is edit the unfolded length and width of the part. In this case, since the part is flat, those values are correct. What I have to do now is input this laser cut data over here on the right-hand side. Now, I can do that simply by typing the numbers in if I know the answers, or I can use the geometry calculator that we have up here in the toolbar to input the dimensions. So if I select the geometry calculator, I first have to define the area of the blank. Well, that's easy. It's a square, and it's 4 inches on each side. And I'm going to add each of those edges to the total perimeter. I'm trying to build up the area perimeter of the blank, and then the area and perimeter and number of any holes that are placed in the part. So far, if I click up at the top, you can see I've got an area and a perimeter of the blank. That's pretty easy in this case. Next, I need to add the holes. Well, I've got one that is 1 3/4, and then I've got 4 that are 3/8. Now, you'll notice there's no perimeter tab here for the holes, and that's because all of the perimeter contributes to the total because it's contained within the outside perimeter, if you will, of the blank shape. And so at this point, you can see I've got all the data in there correct. I can choose geometry, transfer, and close. The software colors these fields in blue to let me know that I've changed them from their default values. And if I click calculate, I see a refined estimate of what the cost of the part would be. And at this point, assuming my machine rates are representative, my material costs are representative, I'd have a very good estimate of what the cost of this part would be. I can click on the machine and I can note the cycle time, 38.85 seconds, and I could edit if I wanted to any of the machine rate or operator rate data to further refine the estimate that I was going to see. But at this level, with the data that has been supplied so far, I'd have a cost here of $1.22 to manufacture this part. And I could use the reporting facilities within here to print out or export the reports to communicate the results with other members of my team.